over to Dennis.
Thank you very much, Oren. That was great. Let me share the screen. Can you see my screen? I hope so.
Yes, we can. Yeah.
Yeah.
Awesome. So first of all, thank you very much for inviting. It's awesome to be here. My name is Dennis, and I'll be in this session sharing how we have scaled and succeeded with real-world applied machine learning at Bolt, and what it can teach you in your journey in becoming ML mature company. A few words about me. I'm engineering manager, and surprisingly, I also act as a product manager for the domain of machine learning and experimentation. So my goal is to enable data teams to be successful, to not repeat the same problems, not solve the same problem twice, and have a default way of getting to the market so that they can be fast and efficient and build new products faster. And since I've been with Bolt from almost the beginning of the data team, I've seen a lot of successful projects. That's why I think I have a pretty interesting perspective on what makes projects succeed or fail. And a bit about Bolt. Bolt is the first European super app with a mission to make urban mobility affordable, safe, and sustainable. And we operate in more than 45 countries and in more than 300 cities with our offerings. And we have more than 75 million customers. I'll be talking about a few things. First one is how to pick the right machine learning model, which is incredibly important if you're starting out or are early in your journey. And I'll show a case study of one of the models that we've built and how we have applied our thinking to do that, so you can do the same. And I'll share how you can scale the machine learning efforts in the organization, how to make machine learning projects cheaper and more predictable so that you can expand it and create more value for your customers. But you might be wondering, what Bolt can tell and teach about machine learning? We are not an AI-first company. We are a company that provides transportation mobility services for the humans and goods. So do we actually have machine learning, and do we have a lot of it? The answer is yes. We apply machine learning in so many domains at Bolt, from pricing, balancing supply and demand in real time, optimizing the growth, solving the matching of couriers and drivers to customers, building our internal maps, preventing fraudsters, doing safety, compliance, optimizing customer support, and so much more across every of our 5 business verticals. And with that, we started with really small. We started a few years ago with our machine learning efforts, focused only on a few use cases, and we expanded to a large variety of projects. And to do that successfully, it was really important to pick the right battles. And as a product manager, you are the best positioned to make those decisions. And let me illustrate what I mean by picking the right battles. You may have seen drawing tutorials that start really simple, and they become really complex really fast. It's very similar with machine learning. This is a slide from a course on Coursera.org. It's an entry-level machine learning course that teaches you that you can predict the house value by using some properties of the house, like the square footage, number of bedrooms, bathrooms, and other properties. So this looks like a simple problem to solve that teaches an entry-level course. And Zillow, largest US retail platform, has tried to do exactly that. And they not only predicted the value of the house, but they acted on it to invest and resell houses later. Did it go well for them? Maybe you have heard recently that they've lost hundreds of millions of dollars because their models were incorrect. They incorrectly predicted the house value and the movement of the market. So if you're wrong with picking the machine learning project and take something that you cannot bite, this can cost to the company and shareholders dearly. Zillow has lost a lot in its market value in the past weeks. So I hope I convinced you now that it's really, really important to pick the machine learning project that you can actually successfully solve with the resources and constraints that you have. And now let's take a look at a few ways how we can discover where machine learning can be applied with a good level of outcomes. The first one is you already have an algorithm that can be proved with the data. And I'll soon show a simple example of how to find such an opportunity. Or you can have a manual expensive process. Think about credit risk scoring. You need to evaluate whether you can give a loan to a person. You would need to look at their transaction history, see if they were successful with all their payments, and determine the risk. But if you're making a loan for a €100 purchase online, that's too much of manual effort. It's not worth it. So if you can make a model that would automate that process, you can unlock new business and revenue possibilities working in a smaller loan market. And many companies have done that successfully over the years. Or Oren has talked a lot about personalization. So if you want to have personalized experience so that customers can get personalized discount, personalized news feed, or just some suggestions, that is also a great opportunity where data can be applied. One example of converting traditional software to machine learning or data-driven software, simple to understand, and you can find so many opportunities like that if you're a company with that at least similar to us in some ways, is you have a piece of code, your developers have a piece of code that maybe if some value is less than some number, do one thing. For example, if the distance to the client is less than 3.5 kilometers, we want to provide the school courier on the bicycle because they're most likely going to be faster on a short distance, and provide a car courier otherwise. But who picked that 3.5 kilometers? Did they pick it 2 years ago and now it's obsolete? Maybe 3.5 works in Tallinn but wouldn't work in London or Paris. So in those cases, optimizing this value with the machine learning and data based on the location, time of the day, and other properties can be a really good and certain win. And when you compound many of those solutions, you can improve your business significantly. Now, I would want to share with you a case study of how we worked with one of the projects. This is a case study about predictive destinations. This is the first machine learning model that you actually see in the app, you see in our product. So when you open Rider app of Bolt, first thing you need to do is to tell us where you want to go. So we can estimate the price and select the driver that can pick you up and how much time it will take them to come to you. So this is one of the first entry points for the client. And you will open up, say where you want to go, you start typing the address or the name of the place. And as you type, you're going to get a list of suggestions, addresses and places. And sometimes you have to type for quite a lot of time until you actually get to a place you want. And we know from the data and product insights, so our product managers understand that selecting a destination, it's a common friction point for our existing customers. And friction points lead to drop in conversion. If you're in a place like Estonia, typing the address can be challenging because there are different letters and weird things that I don't have on my phone on the US keyboard. So we knew that if we could improve this experience of selecting destination, we can improve the conversion, improve the customer experience, and improve our top line and bottom line. So the action that using Oren's template, so if we knew where the clients were going, we could suggest them locations so that we can get higher conversion. Because people don't make trips randomly. You don't wake up in the morning and say, I want to go to some random place. Some people use us to get to work and get home. Some people use us to go to a bar in a specific part of the city after work, or maybe use it occasionally when you have a lot of groceries and you want to take a car to get home. So if we can use your history and your data to provide you suggestions, you would have the list of the places you might want to go to, and this would be a single click, and you're done. Car is coming to you. Sounds like a great idea, makes sense on paper, and there is a lot of ROI calculations that have to be done to make sure if it's worth it. But we decided it was worth it. We saw that this could have significant impact on the conversion. Should we start implementing the ML model? Before you can actually give a task to a data scientist or ML engineer to build a model that will give a list of suggestions, You need to understand how to connect long-term goals of your organization, of your company, to some short-term metrics you can measure. Because if you cannot measure it, you cannot improve it. If our goal is high lifetime value of a customer, this can take months and months to measure if we made a difference. So after we ship the feature and product, we need to be able to know, are we doing the good or are we doing harm to the business? So we have to pick some proxy metric that's can be measured on a shorter time horizon. For example, orders per client. That's a good metric. It's a great metric, but it's still not enough to translate it into a prediction problem that a model can solve. So we have to work backwards again. Maybe in this case, we would use clicks on suggestion as a metric. So if the customers click on suggestions we provide them, probably suggestions are good. It would be a good enough starting point to give a task to a data scientist, but you would also need to have some support metrics implemented. So you would need to track conversion. You would need to track, for example, orders to suggested places, so that people are not clicking the suggestion just to see what's going to happen. So, and this is what you need to have before you implement the model, because otherwise you're going to be flying in the blind without understanding what's happening. Once you're done with the metrics, you need to start. And I would encourage you to start simple and iterate and keep things simple as long as possible. One of the great things to do is to start with a simple heuristic. Sometimes something that can be described in a few lines of code. In the case of predictive destination, one of the good ideas would be to take the most common destination. If I'm most frequently going home, then most of the times, if you show me my home location, I would click on it and go there. Takes very little effort, very easy to implement, and we can then see, does it affect the metric or not? After you have the heuristic and you have measured that integrated, everything works, all your pipeline is working, you can see the results. It's time to implement actual model. Take as simple model as possible for your business problem and deploy it and A/B test it with a baseline to see, are you actually improving? And if yes, then the next thing would be to add more predictive signal. For example, it matters where I am. I'm never going to want to order a car to go home if I'm already at home. So knowing location, knowing maybe time of the day of the week, or what are popular things happening right now, can be a great signal to add to the simple model. And only after you're done with that, you can start to increase the model complexity, taking more complex methods, doing more optimizations, because this will usually, there is so much complexity already in the doing machine learning and getting all the data that you don't want to add one more dimension of complexity of the model. I want to highlight, if you can start without machine learning, there is no shame in doing that. Just call it a model. It doesn't have to be a machine learning model. Let engineers integrate with it and let your data scientists improve and iterate on your model. In our case, that's what we exactly did. And we added a heuristic of last unfinished order location. So if I opened the app, checked how much time or how expensive it would be to get to airport, but I didn't order it, and I opened up again later the same day, chances are I still want to go to airport. Doesn't require any machine learning. You need to remember one number per user or one location. And this, how the app looks right now. This is the first machine learning driven thing you see when you open Bolt app. You will see a suggested your previous search, essentially, as a top suggestion. And you're going to see the suggestions that are based on the usage history, so the place where you want to go. And what it leads to is, for regular customers or even occasional customers, you're very likely going to want to click that. For myself, it's really pleasurable when I open an app and it knows where I want to go, so it takes me zero effort, great user experience. One thing I want to highlight again is machine learning is harder than typical software because you have all the data dimension to it. So you have the software issues, but you also have the data issues. It's way harder to test. It's way harder to monitor. Machine learning can fail silently. So it's really, really harder. That's why you want to keep things as simple as possible. And since you might not even know upfront, can you solve the problem? It's really great if you diversify. So think of your machine learning efforts in the organization as a portfolio problem. So instead of putting all your eggs into one big basket and one high impact project, spread it across several projects. Because not only some projects will take longer and you'll have something else to show and deliver value faster, but every next project should be easier and easier to build. You'll have more confidence in it, and you're going to maximize the total output you create for organization. And now let's move to the part of how can you enable successful machine learning in organization as a product manager. And a big part of successful ML is making it affordable and understandable. Oren talked about ROIs. Data scientists are expensive people. So you really want to make sure that you get as much value as you can from your talent. And one way to look at it is where the time goes in every mile project. Oren mentioned 3 to 9 months for a project. And you might expect that after defining KPIs and getting the initial data, integrating with some tools, the most of the value will go into optimizing the model and finding the best way to improve user experience. But reality is that a lot more time is spent on infra, a lot more time is spent on data, feature engineering, integrations, and that's where a lot of effort goes. And only those red boxes are the ones that create a better customer experience. Essentially, it says there is a lot of overhead. And as a product manager, it's important for you to understand where this overhead comes from. There is a good illustration that talks about it and shows these details that go around machine learning. For every real-world system, there's going to be a lot of effort around machine learning. And the actual machine learning code may be very, very small part of the system because there is infrastructure, there is monitoring, there is all the data part, getting the features, getting the training data, getting the labels. So that actual machine learning prototype is the smaller part of the big picture. This is the bad news. The good news is that industry was working really hard to address that. So there is so much tooling, so many platforms and systems that can help to solve those common challenges. And they are done by cloud providers, of course, like AWS and others. They are done by startups and open source community. So there is a lot of great tooling. And eventually, your team will need to go shopping and pick what it needs when it needs. So this is all incredibly important to us because we have a vision around how ML teams should be running. We want to empower data scientists to work together with product managers to deliver end-to-end solutions and solve the business problem. Not to focus on infrastructure, not to focus on the IT, DevOps, and fighting the bugs on the infra side. We want one data scientist to be able to produce model end-to-end and produce a great experience. So that engineers need only to integrate with it. That should be very straightforward, and you have the model. And this is largely how Bolt operates. We have many, many projects where a single data scientist is delivering the whole project end-to-end with no friction, no handover, not throwing any piece of code over the border to another team and creating another Jira ticket. And that is amazing. And I'll show you later what this resulted in. I want to highlight some of the tech components that we have built or used in our ML journey. And for that, it's important to understand the whole data ecosystem and how we think about it. There is no machine learning without data. So there must be some data lake, some place where the data is stored that you can take, explore, and build a prototype on. There must be a way to transform this data, both in the batch systems for training and in real-time systems for inference. And since you'll have the models, you'll need to manage them, to train them, deploy them, scale them, update them, A/B test. There's also a huge piece about experimentation and metrics and data exploration that have to be addressed in a mature organization. And this is what we've been working on for years to improve to deliver better experience to our engineers and scientists. I want to highlight a few machine learning specific components. And I will start with something that we took off the shelf as is. We are a customer of Amazon SageMaker. We use it extensively for the past 3 years. We've been using endpoints, which is amazing abstraction. This is great separation of responsibilities. We know that data scientists needs to do everything to produce the endpoint on SageMaker, and that endpoint will give an answer to a problem. And it's very easy to integrate with SageMaker endpoints. And we run thousands of training jobs on SageMaker. They are great. We use SageMaker Studio to give more compute for data scientists to do their exploration. We use MLflow. It's a very cheap way to improve the tracking and the reproducibility of your data science efforts. And we use Airflow across many different things, but especially in machine learning. Then let me highlight one part about data. Machine learning needs data, it needs features. It needs them both in training, when you build the model, and it needs them when you actually use the model in the real world. And feature stores essentially allow data scientists, data analysts to create this high-value data, both in offline and real-time world, with very low effort. That cuts down a lot of engineering effort. It cuts down a lot of integration issues and problems with data mismatch. Ourselves, we've been building feature store since 2018, but now you're very lucky because there are many SageMaker, there are many offerings. There is one on SageMaker, and there are others, Hopswork, Tecton AI, that make a managed feature stores. So definitely something worth checking out. And moving from the data and features towards using the model, I want to highlight one of the components we have, because I actually haven't heard or seen anybody talking about it. We have many, many models in production. And if every engineer who works with the model would have to learn how to integrate with it, how to deal with testing and updates, that would mean a lot of duplicated effort across the organization. So we wanted to build a clear boundary of separation. But that engineer only needs to know which model they want to call, bring in all the input, all the features that they have, and they want to get a response. They don't want to care where the model is hosted, how is it A/B tested, what additional features it gets. So we build a model invoker that integrates with models and add value-added services and monitors this. And this allows us to have great bird's eye view of all the machine learning that's happening in the company and know where things go wrong and act on them. I've talked a lot about metrics. Offline improvements that your data scientist tells you that they improve something by 5% doesn't always translate to the real world improvements and things you care about. That's why it's crucial to run A/B tests. And it should be cheap to iterate. And SageMaker provides a pretty good approach to doing that. So you can use it for gradual releases and putting your new version to a very small part of the user base and doing A/B tests. Really great thing, saves a lot of time. If you don't have existing A/B infra, I would suggest to try it out. And more on the closing note, ML pipelines can be hard. They may require a lot of babysitting. Things will fail. Things will get frustrating. Everybody goes through that. That's the cost of the game. So don't get discouraged by that, and automate things as you need and as you go. Ourselves, we've built our internal platform for orchestrating our ML workloads so that all the best practices can be incorporated for every new project. So our data scientists don't need to learn Airflow or Jenkins and build CI pipelines themselves. There is a kind of Lego constructor that allows them to have what they need. And when we did all of that, we achieved pretty good results. The data team started at the end of 2017. Since then, few machine learning projects were built and released. And in the second half of 2018, we started to invest in machine learning tooling. We adopted SageMaker, and that allowed us to start building more and more projects faster and iterate on existing ones with way less effort. So when we talk about ROI calculations of data science projects, we were able to cut down the denominator so that now prototyping and putting project into production will take days instead of months. And I think that if you approach ML projects with a clear head, if you pick the right projects to work with at the first place, manageable projects, depending on where you are and what's your skill set and capabilities. If you focus on the metrics, on the right ones, and keep the technology as simple as possible for as long as you can. If you solve the common challenges once and enable everybody to reuse those solutions, you would be able to achieve the same and scale your machine learning efforts, make ML projects more understandable, and bring value to the market faster. I want to thank you and wish you good luck with your machine learning efforts. And if you're excited to work in a company that uses data and machine learning seriously, we're always hiring. Thank you very much.
Thanks a lot, Dennis. That was a very exciting presentation on how you're working with